Hello dear students, today just I am continuing the chapter vector algebra. Here components of a vector and addition, multiplication and finding unit vectors. Okay, vector joining two points, section formula. Here component of vectors. Component of vectors means just if like this a xi plus yj plus zk, just writing like this. These are our general notation. Position vector of P, where O is origin, R is notation for position vector of P. Here x, y, z, if P is point, then we know x, y, z are the rectangular coordinates. Also it denotes direction ratios of this vector of P. Okay. Here x, y, z, these are scalar quantity. These are scalar component. Is component of R. Scalar component of R. And vector component, we know in the x-axis direction x into I. This is vector quantity. And this is scalar quantity. As into scalar into vector, unit vector. So xi is similarly yj in y-axis direction, zk in z-axis direction, r. These are vector quantity. So these are vector component. Vector component of R. For example, suppose we are given a vector a equals to 2i minus j plus 3k. So what 2 minus 1, 3 are scalar component. Okay, and 2i minus j, 3k are vector component. Means every vector having a scalar component and vector component. Clear? So if this is a vector, then we can say it is a position vector of a point A whose coordinate is 2 minus 1, 3. And also of this vector OA, direction ratios are 2 minus 1, 3 and also direction ratios. Okay, so these are the basic concept, and we can add any of two vector in component form just like simple addition. Okay. So add, subtract and also multiply by a scalar component just like this. Suppose we are given a vector a equals to 5i plus 2j minus plus 3k. This is a vector, given vector. The scalar components are 5 to 3. 5 to 3 are also direction ratios of the point which position vector is A. Vector. Okay. And another vector 5i minus 3j minus k. This is another vector. Okay. Then we can add, simple add, just write it and add as a simple addition. 5i plus 2j plus 3k plus 5i minus 3j minus k. Just add. with I, 10i, minus 3 minus 2 minus j, 3 minus 2, 2k. Just simple add. A subtraction, if a minus b, you can do it also. 5i plus 2j plus 3k minus 5i minus 3j minus k. Just subtract as usual. So 5i cancel, 2j minus minus plus 5j and 4k. So this is subtraction. And if 5a, vector 5a means what? Just multiply 5 vector a by 5. 5 of 5i plus 2j plus 3k. This is a simple technique. 25i plus 10j plus 15k. The simple addition subtraction you can do. Okay. Also, a scalar can be distributed as we require. Okay. Just like this, we can write like this: 5 vector a equals to suppose we are having a constant k, a scalar vector ka is multiplied by 5, then we can write constant here 5a also as you like. Okay, and k, a plus b can be distributed as ka plus kb also. Simple addition, subtraction, and distribution of a scalar quantity during the addition, subtraction, you can do as usual rule. Okay. Now, vector joining two points. Just suppose we are having a point A, x1, y1, z1, another point B, x2, y2, z2. So two vectors we can make, two vectors. Suppose this is origin, so this is OA, this is OB, so OA and OB we can write. We know the scalar component of this vector, OA vector, this is OB vector, this is vector A, this is vector B. Its scalar component xyz, vector component xi, yj, zk, x1, 1, 1, x2, 2, 2, 2. So we can write OA means what? x1i plus x2 z plus x3 k. No. x1 y1 z1. This is x2 I, y2 z, z3 k. These are the two vectors in vector notation. Now we want the vector this AB. AB vectors. What is vector AB? So by vector addition we can say that OA AB, OA plus AB equals to OB. Just we can like this. Here AB equals to OB minus OA. This is vector AB. Vector AB equals to OB minus OA. OB is position vector of B. OA is position vector of A. That is vector AB equals to position vector of B minus position vector of A. This is B. B, position vector of B minus position vector of A. This. That is OB. this minus this, OB minus OA, OB minus OA, this minus this, minus x2 minus x1 I, y2 minus y1 j, z2 minus z1 k. This is the vector joining to points. Okay, if A is a point, B is a point, then OA, OB is the position vector of A and B, and vector AB equals to, by addition, triangular law of addition, this plus this equals to this. We can get like this, AB equals to OB minus OA, just we can get the result. So, by using this, we can find a vector joining two points. Clear? Now, section formula. Just we have already seen in previous class section formula in case of two-dimensional geometry, in three-dimensional geometry, just in the ratio m and mn ratio, there is formula for section formula. So here also, suppose we are having a point A and point B. We are having 2 points and its position vector. Suppose this is origin, then this is vector A vector. Here its position vector A. Similarly, its position vector B. You have 2 vectors. Clear? Now, joining this 2 point. This is a point. This is also point. If we see in 3D geometry or 2D geometry, then x1, y, and z1, x2, y2, z2, just like. For in vector notation, just write vector, position vector, position vector. If this position vector is given in question, then you can see, you can write its scalar component, scalar component. Then this question will be as geometry. Okay, here vector notation. Okay. Now, if there is a point on the vector A, joining line, this is the joining line of AB. If there is maybe a point which divides here, point these two vectors are represented. Now, there is a point R. Okay. If here these 2 points are joined by a vector AB, and in this line segment, these 2 points are joined by this line segment AB, and there is a point R which divides this line segment, maybe internally, maybe externally, because if this line segment divide externally, then point will be outside, here or here. And if externally, then suppose R is a point on this line segment internally, means between A and B, and this point divides this line segment in the ratio m n. AR BR. Just read like this, ratio AR BR MN. This point divides this segment MN ratio. Then the position vector of R, position vector of this R, Okay. C. Suppose, so just take, you can write also here R, because R is our special notation, na? So we are, suppose this is position vector of R. Then this position vector of R can be written in terms of this, just like 2D 3D formula. We write how? M plus N, N plus N, and here M, here N, here x2, x1 plus M plus N, M, y2, y1, just 3D, M, z2, N, z1 upon M plus N. Here in 3D geometry, coordinate geometry. So just like position vector can be found, OR equals to also just like that, M plus N, scalar quantity M, vector B plus N, vector A. Here M, vector B plus N, vector A plus divided by N plus N. This is the formula. Position vector of R can be written as in terms of A and B, where R is internally divisible. If externally, suppose here is R dash, then this value will be M, and this value will be N. In this case, the formula will be OR dash equals to R dash equals to, just only minus sign is there and nothing other, only minus sign is there. Externally, this is internally. Okay? Externally minus minus sign, internally plus plus sign. Externally means outer side, so total value will be M, this will be M. AR, M dash means M, and BR means M. And by calculation you can see that this is the position vector of this R, and this position vector OR dash is this, externally, this internally. Just remember this formula, okay? We will require this formula for solving questions. Now, just by using this idea, concept, just we have discussed now and in previous class, we will solve questions from exercise 10.2, section formula, components, unit vectors, etc. Okay, so just try to solve questions one by one of exercise 10.2 here. So first question, just compute the magnitude. How can you compute the magnitude of a vector? Whenever the values of vectors are given in component form. Just here magnitude finding means solution one, what vector is I plus j plus k. Similarly b, what is b? B is 2 minus 7 minus 3. 2 minus 7 minus 3. I, j, k. Clear? Similarly, c equals to what? 1 by root 3, 1 by root 3 plus plus minus. C equals to also 1 by root 3, I plus 1 by root 3, j minus 1 by root 3, k. These are the given vectors, and just compute magnitude. Magnitude We know magnitude given as what? X square plus y square plus z square. Where r equals to what? Xi plus yj plus zk. So magnitude finding is very simple. Just compare each of the vector with this. That is here x square plus y square plus z square root. That is the magnitude. This is magnitude. Okay, magnitude means here r, here magnitude of a is equals to what? Root of 1 square plus 1 square plus 1 square equals to root of 3. Magnitude, positive square root. Because 1, 1, 1. Here 2 minus 7 minus 3. So magnitude of b is equals to what? Root of 2 square plus minus 7 square plus minus 3 square. Okay, what? 4, 49, 9. Root of 62. Similarly, what? 1 by root 3 square plus 1 by root 3 square plus minus 1 by root 3 square. Just square its square component and sum it and take a square root. 1 by root 3, 1 by root 3, 1 by root 3, 1 by 3, 3, 3, 1 by 3, 3, 3. 3 means what? 1, 1. So these are the values of write two different vectors having same magnitude. Write two vectors, different vectors having same magnitude. Magnitude same, two different vectors. Magnitude same, two different vectors. That means, how can we write two different vectors? Vectors are different if their scalar components are same. Okay, so having same magnitude, two different vectors. Just like 1, 2, 1, 2, 1, 1, we can write like this. Okay, suppose a vector A equals to 1 into I plus 2 into J plus 1 into K, and another vector B 2 into I plus 1 into J plus 1 into K. So if we take this and this, then component A equals to magnitude root 1 square plus 2 square plus 1 square equals to what? 1 plus 4 plus 1, 6. Here root 2 square plus minus 1 square plus 1 square equals to what? 4 plus 1 plus 1 equals to root 6. So magnitude are same. Magnitude same. But both two vectors are not equal. So magnitude are same, but they are not equal as their scalar components are unequal. That is, they are different. This type of combination may be infinite in numbers. Infinite in numbers. Okay. Infinite may be numbers, maybe taking anything 1, 3, minus 1, 3, 1, 1, and etc. as you like. This for equality of two vectors, the components should be also equal, but here unequal, so that vectors are different. Okay. The question third, write two different vectors having same direction. Two different vectors having same direction. Okay. So same direction vector, direction same means if we take vector A equals to I plus J plus K and B equals to 3I plus 3J plus 3K, then we see that magnitude A equals to 1 square equals to root 3 and magnitude B equals to root 3a square 3a square 3a square 27. Magnitude are different. Okay, so different vectors, magnitude is different, but directions are same. Why? We can see that its direction cosine and its direction cosines are different. If two vectors are equal, having same direction, then their direction cosine will be same, or direction ratios of their direction ratios will be proportional. But here we see that direction cosine of vector A is equals to what? We know direction cosines. How can we find the direction ratios or direction cosines? Direction cosines are given by A by root A square plus B square plus C square, B by root A square plus B square plus C square, C by root A square plus B square plus C square, where ABC are direction ratios. Here direction ratios are 1, 1, 1. So ABC are 1, 1, 1. So direction cosines of vector A is 1 upon root of 1, 1, 1 ABC. 1 square plus 1 square plus 1 square equals to 1 upon root 3. Just like this. 1 upon root of 1, 1, 1, 1, 1. 1 square plus 1 square plus 1 square. 1 upon root of 1 square plus 1 square plus 1 square. That is 1 by root 3, 1 by root 3, 1 by root 3. Clear? Here. And direction cosine of B vector equals to 2 upon root of 2a square plus 2a square plus 2a square. 2 upon root of 2a square plus 3a square. 3a square plus 3a square. 3 upon root of 3a square plus 3a square plus 3a square. Clear? Because 3, 3, 3, ABC, 3 upon root 3 square, ABC, 3 square plus 3 square plus 3 square. So you have 3 times of 3 square. So 3 root 3. So this is equals to 3 root 3. 3 square, 3 root 3. So 1 by root 3. 1 by root 3. 3 by root 3. 3 root 3. 3 by 3 root 3. 3 by 3 root 3. That is 1 by root 3. 1 by root 3. 1 by root 3. So these are the same. So direction cosines of A, direction cosines of B are this and this same. That is, direction of A and B are same, but its magnitude are different. So this type of combination may be infinite numbers. Okay. So this is solution of question 3rd. Clear? So just you have to give the reason by logically. Okay? By using definition. Here, question 4. Just take question 4. Question 4 is find the value of x, y so that the two vectors are equal. The two vectors are equal, we know. If two vectors are equal in component form, then their components must be equal. So very simple questions. Just you can do it. Okay. So here x, y, related value of x, y. So for question 4. Question 4 here. Just vectors are given 2, 3, x, y. One vector is 2i, 3j, and another vector is xi plus yj. If this, then 2 equals to x and 3 equals to y. Because if these two vectors are equal, then their scalar component coefficient of y must be equal. Clear? So x equals to 2 and y equals to 3. Question 5. Find the scalar and vector components of a vector initial point 21 and minus 57 terminal point. So here question 5. Initial point 21. Terminal point. Scalar and vector component with initial point and terminal point. This is initial point A, terminal point B. So vector AB. How can you write vector AB? OA, OB minus we know that vector AB equals to OB minus OA, position vector of B minus position vector of A. Here point is A, point is B. 2, 1 and 5, 7. These are the point in two dimensional. Here 2, 1. So we can write initial point this, terminal point this. So OA can be written 2i plus j and OB can be written how? Minus 5i plus 7j. So OB minus 5i plus 7j minus OA 2i plus j. So it can be solved. Just subtract minus 5 minus 2 minus 7i plus 7i minus j 6. This is j. 6j, 7 minus 1, 6j, this. So, vector AB equals to this. Now it's a scalar component, minus 7, 6. A scalar component, minus 7 and 6. Vector component, minus 7 into I and 6j. Just multiply by unit vector along x-axis, along y-axis. just minus 7 and 6j. Okay, so these are the scalar component and vector component. Okay, question, one by one questions we can solve. Just remember the definitions and concept which are used for solving questions. Okay, so here next question is question 6. Sum of vectors this. Find the unit vector in the direction of this. So question 6 is simple, you can do it. Okay, only sum, just write and sum it. Okay, so they are given 2, 3, 4 vectors, maybe just sum it. Plus, 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 and so on. Some coefficient, same the coefficient of I and coefficient of j and coefficient of k, you can get the sum. Okay, question 6. Question 7. Find a unit vector in the direction of the vector A equal to ij 2k. Unit vector here. Question 7. Given vector is A equals to I plus j plus 7k. Sorry, 2k. This is a given vector. Now we have to find the unit vectors in the direction of this vector. Vector means a direction. Okay, it is a given vector. Given vector is this. We have to find unit vectors along this direction. Along this direction means in this way. We have to find the unit vector along or in the direction. Same meaning. Okay. In the direction of given vector A. Which is given by vector A upon modulus of vector A. We know along a vector, just if we want to find the unit vector, vector means suppose we are having a vector AB. This is a direction. We can find its modulus, just divide it. This is a scalar quantity, modulus is a scalar quantity. If by this scalar quantity, if we divide this vector, then this is unit vector along AB. Unit vector means vector with modulus 1, but direction of this vector, this. Okay, so this is the formula of vector. If there are given 3 vectors and say that first of all find sum of these 3 vectors and find the unit vector along this sum of these 3 vectors. So this 3 vector upon modulus of A plus B plus C. This is unit vector along is unit vector along A plus B plus C. Plus A plus B plus C is a new vector. So along that vector, this is unit vector. So this is the concept of finding unit vector. Okay. So here simple, along the vector A, just we have to find the unit vector. Just find its modulus and divide it. We can get unit vector along A. Okay. So this is formula. Just divide it and we can get unit vector. We have modulus of A is equals to root of 1 square plus 1 square plus 2 square equals to root of 1 plus 1 plus 4 equals to root of 6. Clear? Root of 6 Therefore, unit vector along A is A upon modulus A equals to 1 upon root 6. A means I plus j plus 2. K equals to 1 upon root 6 I, 1 upon root 6 j, 2 upon root 6 k. Okay, so this is unit vector. And this is also denoted by A cap. Clear? So this is question 7, root 6, root 6, root 6. Clear? Similarly, we can find the solution of question 8, 9. Just see here what is given. Given is that you find the vector in the direction of, find a unit vector in the direction of vector PQ, where PQ are the points this. Here 3D points are given. So PQ 1, 2, 3, 4, 5, 6. And question 9, for given vectors A equal to this, B equal to this are given, unit vector in the direction of A plus B, the sum. Okay, so 8, 9 are just same type of questions. So here, first of all, in questions 8, what is given? 2 points are given, PQ. Okay, so vector PQ, just we have to first make PQ, vector PQ, and in that direction we have to find the unit vector. That means what? Just here, question 8, P is given a point, Q is given a point. Just we have to find PQ, OQ minus OP. 1, 2, 3, 4, 5, 6. These are given 2 points. So OP and OQ, these are the position vector. So this we can write OQ means what? 4 minus 4i 5j 6k. So 4i plus 5j plus 6k minus OP, I plus 2j plus 3k. This is PQ. 4 minus I means 3i plus 3j plus 3k. This is PQ. Therefore, PQ, vector PQ means unit vector along PQ. So what? PQ upon mod of PQ. So 3i plus 3j plus 3k divided by root of 3a square plus 3a square plus 3a square. Because we see that here, what we can get? 333, its modulus. Mod of this is equal to root of this. So here 3 root 3. 3 root 3, 3, 3 cancel. So 1 upon root 3i plus 1 upon root 3j. 1 upon root 3 k. This is the unit vector. Similarly, question 9. Question 9, here there is 2 vectors are given. 2 minus 1 plus 2k. So that is, we have to find a plus b upon a plus b modulus. Because unit vector a plus b, this unit vector you have to find in question 9. Okay, this unit vector, this unit vector. First of all, sum these 2 vectors. Then find modulus its and divide it. Then you can get modulus of 2 vectors. The unit vector along a plus b. Just what? Here 2 minus 1, 2. So 2i minus j plus 2k plus of another vector is what? Minus plus minus. Minus I plus j minus k. This upon modulus of these 2. Modulus of these 2. What modulus? 2 minus 1 I plus minus 1 plus 1 j plus 2 minus 1 k. Just sum it. Okay, just you have to do it in detail. Okay, So here we can see that this is 0. So z finish 2 minus 1 1 1 square modulus here 1 square 2 root 2. So here 2 minus 1 1 means I plus k upon root of 2 equals to 1 by root 2I plus 1 by root 2 k. So this is vector. Just sum two vector first and then it's take its modulus and that is the and this is the unit vector along a plus b. Okay, this answer of question 9. Okay, 9 means 1 by root 2 plus ik and just 10 11 10 find a vector in the direction of this with magnitude 8. Magnitude. Unit vector means what? Unity. Okay, in some direction. If we can get unit vector in a direction, then for getting a vector in that direction of some multiple or some magnitude, just you have to multiply that quantity to the unit vector in that direction. Okay, so only here for question 10 we can see that question 10, how can we solve this question? Just find unit vector five I minus j plus 2k, 8 units. Okay, so 5I minus j plus 2k. This is a given vector. This is a vector. Okay. So in this direction, vector in this direction. In this direction, just we have to find a vector with magnitude 8. In this direction, in the direction of this vector, magnitude 8 of 8 magnitude vectors, vectors with magnitude 8 in this direction for finding, just we have to find 8 times of a. 8 a cap means a cap unit vector in this direction. Just find unit vector in this direction and multiply it by 8. Then its magnitude will be 8. So here 8 into a vector upon modulus of a. 8 a vector, this is 5I minus j plus 2k upon modulus 5 square plus minus 1 square plus 2 square equals to what? 8 5I minus j plus 2k upon here 25 1 plus 4 6 30 30. Okay, so 8 by root 30 5I minus j plus 2k. You can complete it by simplifying it. Okay, so here minus 8 by root 30. Okay. 11. Show that the vector these are collinear. Okay. So question 11 can be solved. Show that the vectors these are collinear. Okay. Two vectors are collinear. Here vectors 2 minus 3 4. So first vectors, let a vector 2I minus 3j plus 4k and second vector let a and b equals to what given? Minus 4 6 minus 8 minus 4I 6j minus 8k minus 4 plus 6j minus 8k are collinear. Suppose these two vectors are denoted by a and b and they are collinear. We have to prove. Okay. So we know if two vectors are collinear, then we can write A equals to lambda times of B. Means one vector is some constant multiple of other vectors. Either lambda may be positive or negative, and with some scalar. So here we see that vector B equals to minus 4i plus 6j minus 8k. So here minus 2 common. Then we can write 2i plus 3j minus plus 4k. Here minus 2 is common, so here minus sign. So minus 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 4 minus plus 6 and this 2 minus 3 4 2 minus 3 4. So we can write minus 2 times of vector A. So here we see that vector 2 equals to lambda of A, where lambda equals to minus 2, implies vector A and B are collinear. Clear? For collinear vectors, if A and B are collinear, then we can write like this. Lambda is scalar, positive or negative. So here we see that B can be written like this. B is equals to lambda times of A. That is, A and B are collinear vectors. Okay, 12. Find that direction cosines of the vectors. 1, 2, 3. We know direction cosines. How can we find the direction cosines of a vector? Just very, very important topic is finding direction cosines, direction ratios of a point, for a given point in 3D, or of a vector. Okay, of a vector, not point, because just whenever a point is given in 3D space, that means suppose we have given a point x, y, z, then OP is vector. So direction ratios are x, y, z. Direction ratios of OP, of vector. If P is a point x, y, z, then its direction ratios, its position vector is this. Of this vector, direction ratios are x, y, z. That is, if vector is given, just here vector is given what? 12, I 1, 2, 3. Given vector is I plus 2j plus 3k. Suppose this. Its direction ratios are what? 1, 2, 3. Because if a point is given, then you can write position vector xi plus yj plus zk, and xyz is scalar component. These are the direction ratios of OP. These are the direction ratios. So if, and also just we write like this vector. So here vector is given, that's 1, 2, 3 are the direction ratios. If direction ratios are A, B, C, then its direction cosines are a square plus b square plus, just divide it, root a square plus b square plus c square, root a square plus b square. This is the direction cosine. So we can find direction ratios cosine here by using its direction cosines are 1 upon root of 1 square, 2 square, 3 square. Then b upon means 2 upon. Again root 1 square plus 2 square plus 3 square. With 3 upon root of 1 square plus 2 square plus 3 square. That is 1 upon 9, 4, 13, root 14. Clear? So root 14. Okay. 13. Find the direction cosines of the vector joining the point this and this, directed from A to B. So just here you can solve this 13. Here 2 points are given. A is given 13. A is given and B is given. What is given? AB 1 to minus 3, 1, 2, minus 3 and minus 1, minus 2, 1, minus 2, 1. These are given. Then we can write AB. We can write AB. If we can write AB, then this into I plus this into J plus this into K. You can write vector. Then these values will be what? A, B, C. Direction ratios. And the direction cosines will be A upon root of some A square, B upon root of some A square, C upon root of some A square. This will be direction cosine. Just you can find it. Okay. So do it from yourself. Now 14 questions. So that the vector this is equally inclined to the OX, Y, OZ. So here 14 equally inclined. Equally inclined means what? Equally inclined means you can find direction cosine of the vector, and if direction cosines we find equally inclined means, suppose there is a vector x, y, z origin, there is a vector, it is equally inclined alpha, beta, gamma, that is cos alpha, cos beta, cos gamma. If we can show that cos alpha, cos beta, cos gamma, then we can say that this vector are equally inclined to Ox, Y, Oz. That is L equals to M equals to N. That is direction cosines. Direction cosines are equal. Okay. So here the given vector is what? I plus j plus k. So here I plus j plus k. So it's direction cosine are 1 upon root 1 square plus 1 square plus 1 square. Same 1 square plus 1 square plus 1 square. 1 upon root 1 square plus 1 square plus 1 square. That is 1 by root 3, 1 by root 3, 1 by root 3. If A makes alpha, beta, gamma angles with x, y and z axis, then cos alpha equals to 1 by root 3 equals to cos beta equals to cos gamma, implies A is equally inclined with Ox, Oy, Oz. Cos alpha, cos beta, cos gamma, because cos alpha, cos beta, cos gamma, element, so element are equal 1 by root 3, all are root 3. So equally, A is equally inclined, this is equally inclined with Ox, Y, Oz. Clear? Now 15. So 15, find the position vector of a point R which divides the joining of 2 points P and Q whose position vectors are given respectively in the ratio 3 and internal and external. Very simple, internal external division of a line segment by a point and its position vector can be found by simple formula. There are two points are given which position vector what 1 to minus 1. So one point is first point is given here 15. First point is given 1 to minus 1 and another point is given not point minus I plus j plus k minus I plus j plus k. Just like this point are given. Okay. Minus I 1 1. 1 to minus 1, 1 to minus 1. This is OP is given and OQ is given. I plus 2j minus k minus I plus j plus k. These are the given position vector of 2 points P and Q. That is like this. O, P and O, Q. These are given. Just here is a point or here is a point. Here R and R dash. We have to find this and this. OR and OR dash. Just we have to find. Internally and externally. If internally to 1 or if externally to 1. Then we have to find the value. Clear? So, very simple formula we know. What? M plus N, M, B vector. If this is A, this is B. So, MB, this is M, this is N. This is M, this is N. So, M plus N, MB plus NA. Here, M means 2 plus 1. Given ratio 2 ratio 1, 2 ratio 1 internally. So 2 plus 1, so 2 into B, B means what? This vector, position vector, this position vector means here P is here, Q is here. So just revert it, okay? So here 1, 2, minus 1, or here minus 1, 1, 1. This is Q, this is P. Okay. So just write this is Q, this is P. Clear? Now OP. Just for formula here OQ B. This is B and this is A. So A, B means this minus I plus J plus K plus 1 into this I plus 2j minus k. So we can get value. This is equals to here 2 plus 1. Just we can find the value. What? Minus 2 plus 1 minus I 2j plus 2k 4j 2k minus k plus k upon 3. So this is the value internally. Internally is value is what? Just by 3 minus 1 4 1 minus 1 4 1. Okay. Similarly externally just minus it only. What? M minus N, M B minus N A. Just minus sign is used. Minus I plus J plus K minus 1 I plus 2J minus K upon 2 minus 1 equals to here 1. Here we can say that minus what? Minus 3 I minus 3 I J minus 2J plus 2J cancel K 2K minus 1 plus 3K 3K. So this is the answer. Okay. So externally this, internally this, internally this and externally this. Okay. Now just remaining 3-4 questions you can do. So very simple questions. So do it from yourself and send me as your attendance. Just solution of these questions. Just 16, 17. Here find the position vector of midpoint of vector joining the point this and this. Midpoint means just M and R equal. That's just plus by 2. A plus B by 2. You can do. Okay. So 17. Show that the points A, B, C are position vector of with position vector this respectively vertices of a right angle triangle and right angle triangle. Just there are 3 points given A, B, C, the OA, OB, OC. So write AB, BC, C. Find all 3 values. 1 of square of 1 modulus is the square of. If we can get this type of result, then right angle triangle make. And 18 and 19, just which of the following is not true? Just you have to decide it. One by one discuss, and which is not true, just identify it. And 19, if A, B are two collinear vectors, then which of the following is incorrect? Just see here, A, B equals to lambda A for some scalar collinear. Okay, this is the formula. A equal to plus minus B, lambda equal to plus minus 1. Then you can take like this. The respective component of A and B are not proportional. Are not proportional. Then maybe not proportional. Because collinear vectors means they are just parallel to one line. So this is also correct. And both vectors A and B have same direction but different magnitude. Maybe also equal magnitude. Why not? So it is incorrect. D. So just you have to discuss and give logic for the questions 19, 18 and 19. Okay. And identify the answer. And 16, just find midpoint. 17, just find all the side A, B, B, C, C, A and C. Square of 1 is equals to by the square of sum of square of other two. If this you can get, then form a right angle triangle. Okay, so just do 16, 17, 18, 19 and send me for your attendance. Okay, so this was the question exercise 10.2. Okay, in the next class I will discuss about dot product. It's product of vectors. Okay, so for attendance send me PDF file. Okay.